Thank you so much for joining. 7 of you are in the session out of about 70. Who is here? So I'm the 8th person. Thank you for all 7 of you to come and learn. So just a minute, we are going to start module number 4. And module number 4 is about confidence interval. You know,
Join the meeting.
So what we are going to learn, actually, we are also going to learn the inferential statistics. So far, what we were doing descriptive statistics. If you read the book, or if you had gone through chapter 1 or 2, that you must know what is the descriptive statistics, what is the inferential statistics. Do you have some knowledge about descriptive or inferential? Because you are in chapter number 8. Any input? What do you understand by inferential? What do you understand by descriptive statistics? Any understanding? Because now onwards in this chapter and further chapter, we will focus on inferential. Okay, so you have data and you are describing data numerically, visually. That is descriptive. Inferential statistics is this. That means you take the sample from the population, based on sample you explain about population. You, like, out of blood, you take the, the lab person, blood sample people, they take the sample of the blood of 5 ml, and they diagnosed, or they, analyze those blood samples, and they tell that in the report what is the result, and based on result, doctor prescribe the medicine for entire whole body, which is about having 7 liters of blood. So basically, same thing is, we take the sample from population, we do the statistical analysis, and we come to the conclusion about population. We can come to the conclusion with some percentage. I'm 90 for, like I ask you the question, what is your chance, or how confident you are that you will get 4 out of 4 GPA in your MBA? What is your answer? Will you say, I'm 100% confident that I will get 4 out of 4 GPA? Somebody says, I'm 95% confident. Why this 5% or 10%, or this chance is there that you may not get? The same thing is here. So we are going to learn this 95% confidence that I will learn 4 out, or I will get 4 out of 4 GPA, or whatever, I'm 95%. I have 95% confidence that I will get into Harvard Business School. I am 90% chance. So basically, why we call? Because you are confident. The same concept is going to be applied here in this. I'm 90, like doctor says, okay, this is the result of the blood sample. I'm 99% confidence, probably this is the problem, and let's try this drug. So, and even sometimes they change the drug. I'm 90%, this drug will be perfect, but if that is not giving and that is reacting, then doctor change. So are you understanding what is the whole summary, or what is the essence of what we are going to do in this chapter or in this module? Is it making sense?
Yes.
Thank you. Yeah, at least say yes, no, ugly, say something at least. So I can understand, okay, you are there or you are hearing me. Okay, so this is the essence. Now let me tell you. So basically you need to understand these symbols. What is the symbol for population? What is the symbol for sample? Okay, now we come to the, okay, I'm just taking my own data, which is about GPA and research. Okay, so basically this is a sample of 500 students. How much? I don't know. This is 500 and I can see their GPA. I can clearly see in one go. Okay, I can see statistics and basic statistics, and I can see display descriptive statistics, and I can see, okay, all number I'm going to select, and I'm going to see statistics. I'm just going to, okay, I'm just going to see for 2, 3. Okay, I check GRE, TOEFL, GPA. Okay, rest of the things I'm just, okay, I can see the sample mean is this. Based on 500 students, their GRE score 316.4. This is the average of all 500 students. But I don't know, every year from India, about 22,000 students come. And I take the sample of 500 only. This is 500. 500 GPA is 8.5. What is about all 20? I just want to see what would be the sample, what would be the mean of all 22,000 students coming to India? What would be their GPA? In India, here we write GPA 0 to 4. This is a scale of GPA in USA. India is 0 to 10. This is a scale. So on 10-point scale, they give the GPA. Okay. So I want to know about this. How can I know? There's a very simple thing. I just do statistics. And here we have basic statistics, and I can use one sample t-test. And I can use, for example, GRE, and I can use TOEFL, and I can use GPA and perform hypothesis. No, I don't want. I just 95%. Okay, and I can do this. And similarly, I can do for 90% and 99. So then we can compare all three of them. Basic statistics, one sample T, and then I can change to 90%. This is a confidence level. Again, this is confidence level. Like I said, how confident you are that you will get 4 out of 4 in MBA. Statistics, basic, and then you can go for 99, let's say. So we did, by default, all statistics is based on 95% confidence. If you do any analysis, automatically it comes 90. Then you need to change. So by default, it comes to 95. Okay. So what is the interpretation? Like, if I ask you, what would be your GPA in MBA? Jessica, what would be your answer? What would be your GPA in MBA? Just roughly, you can give any random number, any answer. Or Amanda, you can give, or John or Julie, you can give. I didn't hear, please. Hopefully 90. No, I mean, what would be your GPA? So 90 is just, okay. So Melissa has given, she will get 3.8%. How confident you are? 85. Okay. This is one thing. So it's still 15% chances it may not be there. Okay, let's say you live in Spokane. When you will reach to, you are driving from Spokane to Seattle. In what time you will reach to Seattle? 2 hours, 3 hours, 4 hours, 5 hours? 4.5 hours. 4 hours. Okay. So this is good answer. But usually the answer is given, if I'm doing MBA, probably my GPA would be in the range of 3.8 to 3.9. If I'm driving from here, Spokane to Seattle, I may reach between 4 to 4.5 hours. There are many uncertainties are there. So basically, when you give exact answer, that is usually you need to give answer in the range. Okay, between this to that, whenever you target any job for salary, my salary would be in this range. You don't say I need 120,000 or this thing. When somebody asks you the question, you said, in top 5% or, top 15%. So basically that is a range. Same thing is here. So the best option, whenever you answer your question, you always answer in range. My GPA would be 3.8 to 3.85. But again, after that, you say, I'm 95% confident that my GPA would be 3.8 to 3.85. Is it making sense? So look into that, this GPA is for, this is the 500 students. Their GPA is 8.5. All 22,000 students, those are coming, their GPA will be in the range of 8.5 to 8.6, and I am 95% confident. So you see, this is confidence interval for mu. What is mu? What is mu?
Population mean.
Yeah, population mean. So this is about population. This is sample. Based on sample, this is sample mean. We are saying population GPA will be in this range. I'm 95% or 90% or whatever percent I'm confident. Is it making sense to everyone? Though only 7 students, okay? If that makes sense. Similarly, TOEFL, all students coming from India, their population will be 95%. I'm 95 will be in this. Still there is a chance that 5% may go below or above this range. Still 5% chance, anything can happen. This 5% risk is always there. Now, if I increase the risk or if I decrease the risk, what would happen? Let's say here, what percent of risk is here? 5%, that it may not be between this. Let's say I want to take only 1% risk. Then what will happen? I can make a little bit broader range. Let's say I'm 99% confident that my GPA between 3.5 to 4. I increase the range, then I'm more confident. I'm 99% confident. Is it making sense? Then what happened? If you increase the confidence, then you also increase the range, and you can see clearly. So this is, let's say this is 95, 8.5. Now let's look into the 99. So here you can see 99 is bigger range, 8.50 to 8.64. And there you can see 8.52 to 8.62. Let's look into 90%. This is more, the smaller range. So what is your learning? Higher the confidence means higher is the width. So I can show you one slide that can give you some understanding. Okay, look into this. Can you see this? Higher is the confidence, higher, bigger is the width. You can see this is wider, this is wider, this is, and then if I say 60%, basically, because you are taking 40% chances, it may not be in this. So what is your learning? Greater is the confidence, greater is the so 90% is most often used. Okay, if this is clear, the sample size, exactly, that's correct. Greater confidence, yeah, this is clearly, you can see. I can say I'm 100% confidence that my GPA between 3 to 4. Certainly, my GPA, because I can get MBA when I have GPA 3 and above. I'm 100% confidence I will have 3 to 4 GPA when. So the range is from 3 to 4. I'm 99% confidence that my GPA would be this much, between 3.8 to 3.82. So basically, you just remember this slide. Now, another thing, how you can get more precise value of thing? If you have more precise, confidence interval. If you have higher sample size, basically confidence interval is explained by this. So basically, this is the mu plus minus z sigma upon n. So what do you understand from this formula? Look into this. Mu is, this z value remains sigma. So basically, what are the factors that affect the confidence width? Sigma is standard deviation. Higher the standard deviation, that means higher is the length. Means if you have data that is highly, deviated from the mean, then you will have the higher, n value. Higher the n value will have the lower, confidence interval. What is our aim? What should be our aim? Aim must be to have as precise value, as a smaller value with more accuracy. How you can change? You can't do this thing. You can take, you can change the confidence like 90, 95. Only these are the numbers which will change. These are fixed for 90, 90. So like 99, this is fixed. This is fixed for 95. This is for only whatever data you are using, their standard deviation and their sample size. These two factors contribute. Higher the sample size, better is the or more precise result, more precise confidence interval. Lower the standard deviation means, data is good than this. So are you understanding what I'm trying to say? Okay, perfect. So now, so I explained, all devious, all, these distribution follow normal distribution when they come to. Now we come to few things that are important for you to learn. Yeah, another thing, what is this 90, 95 and these distributions? So understand the meaning of 90, 95, 99 and all these percentages. So let me share whiteboard to explain. Where's annotated? Okay, here we have whiteboard. Okay. So let me start with, okay, let's say this is a normal distribution of the population. Okay. This is a mean, what is this now because you already done chapter 7. Okay, you take first sample. So this is a population, which is mu. Population mean or mu I can write here. Okay, and this is a distribution. So let's say I have I mean, I know this is average age of Eastern students, average age of uh, Eastern MBA students. Okay. Let's say X. That I know there are 2000 students about, or graduated and all so far. Okay, their average is like X number. Randomly I take sample one sample I take, like maybe randomly I take a sample of 20 students, and out of 20 I get from my class. Okay, their mean average, that sample one is like their mean is this and confidence is this. Confidence is going from here to here, sorry. Second sample I take and their average is like, because I'm doing all randomly. So this is mean and these are their confidence interval. Third sample I'm taking, this is third, let's say its confidence is like this. Confidence interval again depends on two factors, sigma and n value. Fourth sample I took, okay, I took this. Please follow, I'm fifth sample I took, and this is like, okay. Let's say I take, 10 sample. So sixth sample I take like this, and it's try to understand because this is the most important concept. Seventh is like here. 8 is like, I do this way, this side, and please. Ninth I can write here, which is like here, and that goes here to here. And 10th I can do, let's say here. So now what I did, I took 10 sample. What I take, now you understand, out of 10 sample, every sample is representing true population mean. So this is a true population mean. Mean is X, means their confidential interval is in the range of true population mean, except this. So out of 10 sample, 9 are representing true population mean. What one is not representing. That means I'm 90% confidence. So if you take 1000 times sample and 990 times it, 9,000. So if you take, let's say 100 sample and 99 represent true population mean, that means you are 99% confidence. If you and if 95 represent true population mean, then you are 95% confidence. Similarly, if you say like 90%, 80%, whatever. So confidence interval, you understand what is confidence interval? So confidence interval is mu, and mu is this, and plus minus. So this side is plus, this side is minus, plus and minus, z and sigma upon square root of n. So this value is fixed. Z value, you choose the confidence level pi, and you get the value. Sigma and n, they are variable, and you can decide. You can, based on sample, you can do. Is it making sense to all of you? If no, you can ask me. Everyone, because 7 students, I love to teach, small size. And so I can ask name by name, everyone. Okay, perfect. So this you understand. Now there are 2-3 different cases in confidence interval. And please, so this is, now what is confidence interval? So I already explained this. So what is this is standard error. Now I have to, so after plus minus, the value is margin of error, and this part is standard error. When you include, oh, no screen, sorry. Thanks. So X var or mu plus minus, okay, then Z sigma upon, sorry, here, a small s, because we are talking about sample, upon a square root of n. And when we are talking about this, when we have to do t. So mu Z and sigma and square root of n. So after plus minus, this term is called margin of error. What is the name? Margin of error. And only this standard deviation divided by n is called standard error. So this is called standard error, and this whole called margin of error. So please remember these terms. And after that, so you understand mu plus minus. If you have two values, you can do that. Means if you have this formula, one time you are subtracting from mean, you are getting negative side. One time you are adding, you are getting positive side. So this is how to do in Minitab. Here you go under statistics, basic statistics, one sample, one sample T and one proportion and one variance. These are the options that you are going to do. One variance, one proportion, one this, and you are going to do this. These 4 options. So this I already explained. Now, when remember, I go on the summary slide. So please remember all these things. This is very important. Okay, this is the summary slide. When do we use z-test? When we use t-test? When we use proportion test? All these are here, right here. So if you look into this, this is when standard deviation is given, population standard deviation given, we are going to use this z-test, one sample z. What we are going to use? One sample z-test. Oh, sorry, one sample. When sample standard deviation, when population standard deviation is not given, we are going to use t-test. So this is a t-test, this is a z-test, and this is a proportion. Is it making sense? Okay. So basic. Yeah, go ahead.
Repeat it? You said when the population is given. Yeah, the first one. Do you mind repeating all of what was given?
So you can see the, just, this, leave it for now, this part, leave it, this n upon n. Just look into the formula. What difference you see? Here you see z, and here you see alpha. Sigma. Here you see t, and here you see small s. This is the difference. So sigma, what is sigma?
Population standard deviation.
Yes. When you have population standard deviation known, then you use z-test. Z. Okay. When population standard deviation is not given, this is, you can do all based on sample. This is sample standard deviation. Then you use t-test. What we have done so far in our this case, we used, okay, I can show you. We used t-test. Look into that. Basic statistics, one sample, we use one test, t-test. And here, when you use t-test, so automatically it calculates the, mean value, automatically it calculates the sigma value from here, automatically it counts, 500 sample size, everything. And you don't need to, so this is a t-test. When you look into this statistics, one sample, here it clearly asks, okay, I'm just, for example, the same thing, ZRE, research. Okay, I have to do one at a time. Let's say ZRE. Now, here I have to give the population standard deviation. If I know from some data or something, 10 is population standard, then only it will run. Otherwise, you can't do this. You can't do. So if you know the population standard deviation, you are going to use Z, otherwise you are going to use T. Is it making sense? Everyone?
Yeah.
Perfect. So, yeah, this is. So this is, these are the formulas for proportion. I will come on proportion, in a minute. So you can see this. This is P. What is the P and pi difference? What is the, you remember the notation? P is sample proportion and pi is population proportion. Is it? So let's see. I have the data here. So when you can use proportion, you can use like, when you have research university or not research university. What is the proportion? Excuse me. What is the proportion of research university? How I can get? I can go here, statistics, basic statistics, and I can use the descriptive statistics, and I can just remove all of them. I can see research, and I can, okay. And I can see mean is 56%, 0.56. Means whatever number, 500 out of 500, 56% are research university. Okay. So, out of 500, 56% students applied for research universities. What about all 22,000 students when they will apply? What would be their confidence interval? So I go under statistics, so basic statistics, one proportion, and I can do the research one, and by default, I can see the 95% and let it be. You can you see the numbers that are right here? So, it is 56% based on sample, 50 sample proportion is 50. What about all the population, all the 22,000 students? What would be their research university proportion? So 51 to 60% will, in this range will apply. I'm 95% confident that 51 to 60% students will apply to research universities. Is it making sense?
Yes.
Okay, perfect. Now, where am I? Look into. So you understand what is the three different formula. Now, fourth, this is called finite population correction factor. So basically this factor n minus capital N is population minus sample divided by population minus 1 and then square root. This part is added in all three formulas, all three equations. This is called finite population correction factor. Means when you have, like it is given out of 2000 MBA students, I'm taking a sample of 500, I'm taking a sample of 68 students. So 5,000 is total population of MBA students, 68, 5,000 minus 1. So basically, what is the meaning here? You can see population is always bigger. Population is always bigger. So basically, let's say I'm just, out of 2000, I am taking 500, sorry, let's say 100 for, rough figure, divided by 2000 minus 1. So this factor is always about close to, less than 1, always less than 1, because you see, this is, if one sample, if you take one sample, that is not a statistics, you have to have good amount of sample. So look into this. This is always close to. So this is always, 1 less. So basically this is very, close to 1, but, about 0.9, something like that. So this is always less. So if multiplied with this, it reduces this value. That means it decreases or it gives more precise number. Is it making sense? So this is called, if you have a clear information that there are 2000 students in MBA, or whatever you are doing, let's say there are 5,000 students in public school and you are drawing 200, because you can get this information from public school administration. We have 5,000 and you can draw. So this is called finite population correction factor, and it gives more precise value, more precise confidence interval. So the purpose is that you want to get more precise range, more precise or more narrow range with higher, with good confidence, or, with. So this is the purpose of this, that you can know about this. So this is a proportion. So I think I covered almost everything in different aspects. I think I covered everything. So basically, when you are going to use Z, when you are going to use T, now let's say you want to do for this variance. Variance, what is variance? So I'm just going to tell one more thing. So let's say, I'm going to do a standard deviation. So let me do only one, which is GPA and GPA statistics. Oh, sorry, I did mistake. Statistics basic, and I need to collect standard deviation. So this is standard deviation, and I do. So standard deviation. So, of 500 student, GPA standard deviation is 0.6. What about all 22,000 students standard? In what would be their GPA standard deviation? I need to check how I can do statistics, basic statistics, one variance, and GPA, and I can do sample in each column. I don't know. I don't want to do, and option here, I by default it is 95%. Now this is, these are two different. Chi-square is saying, standard deviation is this, variance is 0.366. So chi-square for sigma. So basically standard deviation is this, chi is using. So 60%, 0.6, it could be in the range of 0.57 to 0.643. Is it making sense to you? How do we compare, based on mean, based on standard deviation, based on proportion, and based on what mean, standard deviation, proportion. These are the three things. Based on that, we estimate population, mean, standard deviation, and proportion. Is it making sense to everyone? If this is making sense, the last concept of the chapter is how do we determine what is the sample size. Let's say you want to conduct a study about something. What should be appropriate sample size? Let's say I'm going to conduct a study based on student satisfaction of online MBA in Eastern Washington. There are 2,000 students. If I get all of them, probably some are graduated, some are not interested to fill out. Okay, how many? Should be the appropriate sample size? 20, 30, 40, 50. What should be the sample size? How I can decide? So basically that decision is based on the sample size determination. And here we have statistics, Popper, and sample size estimation. And here you have different options. So if you know the standard deviation of that, you can determine. If you know margin of error, what is the margin of error? I already explained what is the margin of error. After plus minus sign, that is margin of error. You based on standard deviation, based on variance, based on different options are there, you can determine. So let's say I'm going to do a mean, parameter is mean, so I'm going to do a standard deviation, and let's say I find for this 605.605. what is the margin of error? So let's say, how can I see? Okay, I'm just going to do 0.3. I have different options, two side, assume. Okay, sample size 16, because I put a lot of margin of error. So I can see the 16. Now let's come to the concepts. This is also, when do you assume normality? How do you assume normality? You remember this concept from previous chapters? N pi equal to greater than 10, n1 minus. So this, please remember all those thumb rule. This is proportion. These are for, now here we have how to estimate. So very simple. So X margin of error X plus minus, let's say I'm just T, or I'm just T sigma upon square root of n. This is margin of error. Now I write this margin of error equal to, like, for T, for sample. So this is the margin of error equal to Z sigma square root of n. So this is the formula of margin of error. Now I make, I solve this, so I make a square here, I make a square here, I make a square here, I make a square, which becomes n. Now I put n here and I do everything else on this side. So n equal to ZAE whole square. So based on that, I can calculate. Now sample size and Z value you can get from table, like 1.96 is clearly given for 90. Sigma value, how you can estimate sigma, you can estimate the margin of error, or margin of error is given. How? Let's say sigma, how you can get, that when you do the normal distribution, if you remember this range, entire range, this is range from here to here, almost 99.6.73% of data comes from within 6 sigma. So this is like 0 plus 1 plus 2 plus 3 minus 1 minus 2 minus 3. So within 6 sigma, the range is there. So range equal to 6 sigma. Okay, now we want to see the sigma equal to range divided by 6. And now range you can simply understand, let's say the age of the pupil, or the youngest person in my class, and oldest person, you can see the range, and you can estimate sigma this way. margin of error, sometimes, people give that 5%, 10% margin of error can be. So you put these value, 10%, you put the sigma value, you can do, and you can get this. You can get the sample size. There are methods to do it. One thing, before doing actual practical, you can do the sample. I mean, you can do pilot study. Based on pilot studies, suppose I can take a 10 students data, or I can take 10 students age, and based on that, I can calculate the margin of error, and I can calculate the sigma based on 10 or 20 students. That I can put in this formula, and I can get the n size. Similarly, if you assume uniform population, if you assume, this normal population, like I explained, this concept is about normal population. If you assume the Poisson, then, sigma equal to square root of lambda. So basically, sigma can be estimated using different technique. How to calculate this allowed error? So you would need to a sample size. So it can be between 0 and 1. So any 5%, 10%, 20%, you can, based on expert opinion, you can decide, and you can decide the sample size. Sample size for proportion, the same, the same way to do this, how you do. Here, let me remove these things. You can clearly see this is the formula, this is formula, this, Z value is clearly, ideally 50-50 is the consideration. Whenever you do, suppose you are going to do some thing, you can assume 50-50%, which is ideally. Error, the same way you can do the error, and you can calculate this. So, assume first thing is 50%, then, this, and so basically this is, now chi-square is distribution for, variance and standard deviation. So this is a chi-square plus minus side, and this is the way to do this. So chi-square distribution, you can see the sample size minus 1 degree of freedom, and you can see the chi-square using this. So I go here, I go graph, probability distribution, chi-square, where is chi-square? Here, and then degree of freedom, let's say I want to put 15, 16 sample size, that means degree of freedom 16 minus 1, shaded area just 5%. Okay, there we go. So this is, I just put on the right hand side, if you put both thing, you can get the value of, okay, let's do it. This is so this is module number. Yeah, here, make sure few questions are related to sample size determination, power, and sample size. What information is given and what you are going to. So basically look into that. The standard deviation given, this given, if sample size is given, you can choose, anything. So this is about chapter number 8 or module number 4. If you have any question, feel free to ask.
So with chi-square, is that basically a distribution that shows from a sample, like to the population, what the distribution of variance is? I just want to make sure I understand.
Exactly, so for mean, or, mean and mean, the normal distribution is there. For variance, chi-square is the distribution to check. There are different distribution like binomial, you see, Poisson, you see, hypergeometric, you see, chi-square distribution, app distribution, there are other distributions. So chi-square, whenever you do this variance related thing, or you are going to use chi-square. Is it making sense?
Yeah, that makes sense. Thank you.
You're welcome. I mean, you can see the chi-square distribution at the back of your book. I mean, last pages of the book have the solution, different distribution tables and all. Any other question, please feel free to ask. If you don't have, then I would like to say a wonderful evening, wonderful and productive week ahead, and we will see next week.
Thank you, Dr. Dwavetti.
Most welcome, sir. Hmm.